Good evening, students. I hope you're able to hear me, right?
Yes, sir.
Okay. So, yeah. See, since we are done with the term 1 portions, I just wanted to find out if you guys have any doubts, like you can let me know there is any topic or concept that you want me to explain again that is troubling you.
In any lesson, sir?
Yeah, any lesson, any lesson. Any
Could you
lesson that is
explain
just
that exercise 6.2 applications? The
6.2
of what
increasing and decreasing.
Yes, sir.
Okay, you want the concept or you want the problems based?
Concepts which you use for the problem, sir. The steps we use for different types of that.
So shall I explain with examples then?
Yes, sir.
That will work, right? Okay. Okay. So you're asking about increasing and decreasing problems.
Yes, sir.
Okay. Let me share my screen. I actually thought you guys will have doubt with maximum minimum problems.
Sir, yes, sir. Maxima and minimum also, sir.
Yeah.
I just know. I thought of asking maxima and minimum, sir.
Yeah. I know you will have it. That's a topic generally which troubles people. You know. That's the reason I kept this chapter open. Rohan, I just wanted to find out: is there any set of problems that you already tried, but you feel that your method was different from the answer? So you can let me know something like that. I can help.
7th question and 9th question.
Okay, 7th. Okay. 7th and
9th. Those type
7th.
of questions.
Those type of questions. Okay. The basic algebraic, these kind of functions you
Basic ones I am able to do, sir.
Basic things you are able to do. Okay, that's good. So is there anyone else also having problems with these kind of problems?
Sir, before solving, could you just revisit again these topics, sir? Like, give a brief description on about this increasing and decreasing and start doing, sir.
I can give that, but I told this 3-4 times. So what I'm trying is, there are 2 types of functions. What are they? One is called as increasing and decreasing. Correct? So what is the condition for a function to be increasing? What are all the conditions you will follow to verify whether the given function is increasing or decreasing?
F dash x should be greater than 0.
Nikhilesh, can you come a little closer to the mic?
To be increasing, then f dash of x should be greater than 0.
Yes, f dash of x is greater than 0. We generally call it as strictly increasing.
Greater than or equal to?
Then we call it as increasing. This point you remember, right? Similarly,
Yes,
if f dash of x is less than 0, we call it as strictly decreasing. And f dash of x is less than or equal to, we call it as decreasing. As simple as that. Okay. So the challenging part in this, I think I've already told the reason why it is so. Because if you look at the graph for it, what does an f dash of x with respect to a graph mean? So f dash of x with respect to a graph basically means it's the slope of a tangent at a particular point, right? So if you draw the tangent to a curve which is increasing, then tan theta is nothing but f dash of x. So tan theta is always greater than 0. Accepted?
Yes,
When
sir.
I talk about an increasing function, when you draw a tangent to the curve for to an increasing curve at any point, then the theta will be an acute angle. When it is an acute angle, tan of an acute angle is always a positive value. That is the reason why f dash of x is actually greater than 0. Whereas when you draw the f dash of x, when you draw the tangent for a decreasing curve, what will happen? Tan theta will be equal to f dash of x and theta will always be obtuse. So tan of an obtuse angle is always less than 0. That is the reason why f dash of x is greater than 0 or less than 0, depending on whether it is increasing or decreasing respectively. Okay. Right. Next is, when you have these kind of problems, okay, when you have problems like this, you see most of them miss to check the domain of the function. Right. So if you look at this question, y is equal to log of 1 plus x minus 2x divided by 2 plus x, where x is greater than minus 1 means the domain itself is minus 1 to infinity. Our job is to prove that this is an increasing function throughout its domain. Means if I'm able to prove that f dash of x is greater than 0, but not for all values of x belongs to R. No. For all values of x that belongs to minus 1 to infinity. Correct?
Yes, sir.
So what is the only option we have? It is, since it is an application of the derivatives concept, we will try to solve the problem using derivatives. I want somebody to read the question. Y is equal to log of 1 plus x
1 plus x minus 2x by 2 plus x.
2 plus x.
Yes, sir.
Okay. Now, what is dy by dx? 1 by 1 plus x into derivative of 1 plus x is 1 minus, I hope you guys remember the chain rule, right? Derivative of log is 1 by whatever is the value inside into, if the value is anything other than x, you need to follow the chain rule.
Yes, sir.
Right. Now listen to this.
Yes, sir.
Minus 2 plus x into u by v. That is a product rule. 2 plus x into 2 minus 2x into 1, the whole divided by 2 plus x, the whole square. So 2x and 2x are gone. Right? What is that you're left out with? 1 by 1 plus x minus 4 divided by 2 plus x, the whole square. So after this differentiation part is over, now you need to take LCM. 2 plus x the whole square minus 4 into 1 plus x the whole divided by 2 plus x the whole square into 1 plus x. So what do we get? 4 plus 4x plus x square minus 4 minus 4x the whole divided by 2 plus x the whole square into 1 plus x. So 4x cancel, 4 and 4 we get cancelled. X square divided by 2 plus x the whole square into 1 plus x. Now observe, this is dy by dx. You need not sit and solve this problem. If you are able to prove that this is strictly greater than 0 for all values of x greater than 1, you can prove that it is strictly increasing function on the given domain minus 1 to infinity. So least value that you are allowed to substitute is minus 1.00000001, means you cannot substitute minus 1. Now if you observe, x square is always positive. 2 plus x the whole square is always positive. And 1 plus x is also positive for all values of x that belongs to minus 1 to infinity. Correct? Minus 1 open bracket. So positive by positive is obviously going to be greater than 0. Hence, it is a strictly increasing function. Rohan, am I clear?
I have a doubt. So in exam, how do we write it, sir? Should we explain all this?
You have MCQ there. You need not explain. But you should
Yes,
know.
okay, sir.
You should know it.
Okay, sir. Understood.
Okay. But ninth, can you try ninth one now? Can you at least differentiate? Tell me what is the value. Do it fast. Guys, try this problem.
So
Tell me. 1 minute. 1 minute. Charge is getting over in my page. It's dropping very fast. Yeah. Y is equal to 4 sin theta by 2 plus cos theta minus theta. How much is it? How much is f dash of x? It should be 2 plus cos theta. 4 cos plus 4 sin square theta.
So should we simplify the whole thing, sir?
Yeah, it is, then you will be able to solve it, no?
I think it will be 8 cos theta plus 4 by 2 plus cos square.
8 cos theta plus 4 minus plus cos theta the whole square divided by, corrected? Are my steps correct? Anything am I missing? So 8 cos.
Sir, I'm getting cos theta into 4 minus cos theta by 2 plus cos theta the whole square.
I think that is what I get. 1 minute. 4 and 4 are getting cancelled. You will get 4 cos theta minus cos square theta, correct? Divided by 2 plus cos theta. So
Cos
this is
theta
f dash.
common.
Yeah. No need to take it. So this is f dash of x. Right. Okay. You want to take, well, let's take cos theta common. So you get 4 minus
Cos theta.
cos theta divided by 2 plus cos theta the whole square. Okay. Now what did they say? Is an increasing function for all values of theta that is between 0 to pi by 2. So between 0 to pi by 2, cos theta is always positive. Because first quadrant, 2 plus cos theta is positive for every value of cos theta. And 4 minus cos theta is also positive because cos theta in the first quadrant lies between 0 to 1. So 4 minus a value which is between 0 to 1 will be positive. So positive, positive, and positive. What will answer be? Obviously going to be a positive. Right? Hence it is an increasing function. So when you have these kind of trigonometric problem, this is how you think. Shariyada?
Yes, I understood.
That's simple. Shall we move on to the next part? Is there any other problem that you want me to do?
No, sir, not at all.
Next is the concept of maxima and minimum. All right. So tell me, what is the condition for maximum? So what is the condition for maxima or minima at a point? F dash of x equal to 0. F double dash of x should be less than 0. What is the condition for minima? F dash of x should be equal to 0. F double dash of x should be greater than 0. Right. What is the reason for f dash of x being equal to 0? Because at the point of maximum or at the point of minimum, when you draw a tangent, those tangents will be parallel to x-axis. Right. So tell me if there is any problem that is bothering you.
Sir, possible can I give an algorithm to solve, or like general algorithm to solve the problem, sir, for maxima and minima, sir?
See, unless it is mentioned, unless they mention it as a second derivative test, if they say the first derivative test, okay, unless if they don't mention anything about the derivative test, which derivative test is to be followed, you can solve using the second derivative test itself. Okay, so you can, like when you do the second derivative test, first step what you need to do is differentiate the function once and equate it to 0. Okay. When you equate it to 0, you will get different values of x. Let's say x is equal to x1, x2, so on you get. If you get one x1, if you get one value of x, okay, well and good. If you get multiple values of x, then what you're supposed to do is, you have to go with the, see, even if you get one also, you have to do this. Do the second derivative test. In the second derivative test, substitute the value of x1, x2, x3 in the second derivative. So depending on whether when you substitute x1, it is going to give you less than 0 or greater than 0, it is classified as maxima and minimum. So for example, if I take y is equal to x square plus 3x plus 1, the first step is they're asking me to find the points of maxima. Then what I will do is, okay, I'll take something like this x square. So dy by dx is what I'm going to do. It will be 2x plus 3 and I'll equate it to 0. So x is what I'm getting, x is equal to 3 by 2. So what is the second derivative? D square y by dx square is equal to 2. Now I need to check the second derivative. First of all, it is independent of x. And second derivative is positive. So what can I say? At x is equal to minus 3 by 2, this curve attains a point of
Minima.
That's it. So those are the steps to be followed. Wait, let me take a problem and then solve it. Suppose I take this problem, okay. F of x is equal to 3x power 4 plus 4x cube minus 12x square plus 12. Tell me, y is equal to 3x power 4 plus minus 12x square plus 12. Okay, what is dy by dx? 12x square plus 12x square minus 24x plus 0. If
Sir,
I equate this,
the 12x cube should come.
12x cube. So if I take 12x outside, if I take 12x outside, it is x square plus x minus 2, which is equal to 0. So 12 I can take it to the other side. So I'm left out with x into x plus 2 into x minus 1 equal to 0. So what are the critical points I'm getting? X is equal to 0 or 1 or minus 2. So I'm getting 3 points. Now what I need to do is I'll perform the second derivative test also, d square y by dx square. So second derivative test should be performed from here, okay. One common mistake that happens is people will perform for this. So generally you would have taken the 12 outside, no? So the second derivative will not be right. I mean, so what, see, some students I've seen, they do it from this step. What is the mistake by doing from this step? Tell me.
We'll get the answer as 1 equal to 0.
You took the 12 to the other side.
Yes,
right? But actually, second derivative is for whom? Second derivative is for the first derivative. So this is the first derivative. We need to be careful with that. So what is the answer? 36x square plus 24x minus 24. Right? So d square y by dx square at x is equal to 0. Substitute it. It is minus 24. D square y by dx square at x is equal to 1. It is 36 plus 24 minus 24, which is 36. Similarly, d square y by dx square at x is equal to 2. X is equal to minus 2. Is 36 into minus 2 square plus 24 into minus 2 minus 24. This is 144 minus something. There is also positive less than 0. Now you tell me, guys. There is a point of maximum. There is a point of minimum, and there is also a point of minimum. So these are the steps to be followed. If suppose f double dash of x also comes out to be 0, f double dash of c comes out to be 0, then that point will be the point of inflection.
Sir?
Tell me.
Sir, substituting the values of x in the second derivative test, no, sir.
Mm-hmm.
We can simplify the equation and also substitute, no, sir. Like, will the answer be the same or will it change, sir?
Simplify means
So here 36x square plus 24x minus 24 is given, no, sir. We can take 12 common and take it to the other side. 12 will
that
get...
will be the same. That will be the same.
Okay, sir.
Unless you don't remove any multiplication factor, it will be the same.
So I have a doubt, sir.
Tell me.
In the example before this, sir, where we got a point of minima,
This one, huh?
yes, sir, in this one which we did. Can we
Okay,
find point of maxima from a point of minima, sir? Like since 2 is point of minima, can we find point of maxima from that? That is
No, you can't do that. You can't do that. See, the point of
we
you
have
need to
to
understand.
work.
Wait. See, there are two ways to look at these problems. Okay. I would not suggest the first way where you guys are looking at it more technically. See, you're concerned about finding the maximum value or minimum value, something like that. But I want you all to think in terms of a graph. So the function that is given here is f of x is equal to 3 plus mod x. Okay. You need not follow differentiation at all for this kind of simple problems to understand. Since this time it is luckily MCQ, you can solve it using logic also. Okay. But to make you understand the concept, what I'm trying to say is, if you look at them graphically, I'll ask certain questions, answer them, you'll get your answer. If I ask you what is the graph of f of x is equal to mod x, then what will you say? F of x is equal to mod x looks in the shape of a V. F of x is equal to mod of x plus 3 is nothing but a graph which is shifted in the upward direction, correct?
Yes, sir.
Now you tell me if you look at the graph itself, tell me where is the point of minimum? Is this not the least point?
Yes, sir.
Least value of function. So where is that least value of function occurring? It is occurring at 0, 0. So when you substitute 0 there, the least value will come out as 0, 3. So the function value at x is equal to 0 is 3. Now you tell me what is the maximum value? The graph is increasing.
Doesn't have a maximum value.
So the maximum value is infinite. So how will you find it using the concept of minimum? So finding the value. Yeah, you can't do that. That is the meaning. Okay. So come out of that differentiation thought process and look at the function and try to understand we are finding the maximum or minimum value of whatever function they are given us.
Okay, sir.
Okay. See, for example, I did this problem, no, x square plus 3x plus 1. This x square plus 3x plus 1 is nothing but this kind of a graph. It's an upward parabola. From the basics of your 10th standard, you know that if you have a second degree polynomial whose coefficient of x square is positive, it's an upward parabola. Correct, Ada?
Yes, sir.
So that is the meaning. It is going to be some random U-shaped parabola for which the minimum value is occurring at minus 3 by 2. That is the meaning of this point x is equal to minus 3 by 2.
Understood, sir.
Okay, means to put it in a different perspective, what I'm trying to say is, see, this kind of a graph will have infinite number of points in it. Out of those infinite number of x values, what is the value of x that will give you the corresponding y value to be the least? Okay, the corresponding y value will be least only at x is equal to minus 3. That is the meaning. Okay. That's it. This is how you solve the problem based on maximum.
Sir.
Tell me.
Sir, what to do if the f dash of x is 0, sir?
F dash of x will be 0. Huh?
No, sir. The value of x is 0, sir. We're like finding a solution for x, no, sir.
You can come substitute that x is equal to 0, like how we did in this problem. X is 0 only. No?
Okay, sir.
X is equal to 0 is one of the points. No?
Sir, here you just took the 12 to the RHS, no, sir? Why can't we take 12x to the RHS, sir? Actually, I thought of doing like that.
You can't take 12x because you don't know what is the value of x. See, always whenever you can, I think I've already told this to you guys. 3x is greater than 2 then x will be greater than 2 by 3. You didn't get it because you took the 3 to the other side. You actually divided with 3 on both the sides. See, for example, if x is greater than 2, can I say divide with 0 on both the sides? Does that make sense?
No, sir.
Every problem with this word can be solved by dividing with 0 on both the sides. We don't need math at all. Correct? So since this kind of an operation is not allowed, like what you're asking is 12x is equal to 0, no? Means, okay, I'll explain what is the mistake in your thought process. Into x square plus x minus 2 is equal to 0, no? You're taking the 12x to the other side means you're dividing with 12x on both the sides. What if the value of x is 0? When you don't know that value, means you're actually, without your knowledge, you're doing 0 by 0 format. Which is wrong. You're able to understand. So 12 is taken to the other side only because it's a fixed number. We know what it is. But but the variable cannot be taken. Okay.
Yes, sir. Okay, sir.
Have this point in your mind always. Don't do that mistake. Next. Next, what are the doubts you have?
Sir, for finding the maximum and minimum for that three-dimensional figures only, sir. For that, they're asking the trapezium and asking us to find the length, no, sir. Those type of sums on troubling.
Statement problems are a little bit tough for you guys. Okay. So I'm see generally these problems used to last year since the pattern has changed to this thing they changed. They used to give this for 5 marks last year. Definitely you will get a question from these statement based problems, but I'm not sure how they are going to ask this year because you will not have problems which are based on prove that. Or sometimes what they will do is they'll change the prove that to something like this. Okay, let's take an example. Instead of saying prove that the radius of the right circular cylinder of greatest curved surface area, which can be inscribed in a given cone, is half of that of cone. What they will say is, for a given right circular cylinder of greatest curved surface area, the radius is equal to 2 times h. Or they'll give you options like this: r is equal to 3h, r is equal to 4h, and r is equal to 5h. If they give options like this, you'll have to take it. So first, we need to understand the concept. So I'm talking from a student's perspective, like I'm able to understand what the difficulty you're facing. So first challenge that will come is, most of you will not be able to, you'll be able to understand the question, but you'll not be able to put it as a diagram. That is the first thing, right? So to practice that, I will suggest you the method which I follow, or the way I think. If this works, I suggest you guys also to try it like that. So I took a random problem. Okay, this is a problem which is based on geometry. First always dissect the question. Don't be in a hurry to draw everything at the same time. So prove that the radius of a right circular cylinder. So what is the object you have? You have a right circular cylinder. Okay. Prove that the radius of the right circular cylinder. So let's say the radius of the right circular cylinder is capital R. Of greatest curved surface area. So it has a curved surface area and it should be greatest, which can be inscribed. What do you mean by inscribed? Which can be put inside something. Which can be put inside what? Inside a given cone. So in this type of question, the word given is very, very important. Can you guys tell me what is the meaning of given? Of a given cone means
It's fixed, sir.
Its dimensions are fixed. Because here they didn't say that the cone is moving or it is at a stationary position. No, it is not a physics-based problem. So its dimensions are fixed, means its radius and height and all those things are going to be fixed. Are you able to understand it? So now since we have read the question, let's try to put it as a diagram. So what is that we have? We have a cone which is given. Okay, let me say the radius of this cone is r and the height of this cone is small h. inside this, what are we doing? We are putting a cylinder. Okay. And let's say the radius of the cylinder is capital R and the height of the cylinder is capital H. Am I clear till this point? Is the first step crossed?
Yes, sir.
Correct? Right. So this is the first step. Now label it. Obviously, you need certain points. So let's label them as A, B, C, D, E. Okay. Now, they're asking us to prove that the radius of this capital R is equal to half of that of cone. Half of the height of that cone. What challenge you might face this year? As I told you, they might ask you a question, capital R is equal to 2H, R is equal to 3H, 4H, something is there like this, right? So you'll not know what exactly you're going to get. So let's assume it is XH. So I'm thinking in such a way that our job is to find what is the value of X. Okay, just did this light modification, right? Now, when you have these kind of geometrical based problems, okay, especially cone and cylinder are getting involved, my eyes always look for right angle triangles. Okay. Now we need to ask certain questions. So these are all the questions you need to ask before you solve. How many variables do we have? Okay. How many variables are there?
One, sir.
Capital R, capital H is a variable. There are two variables because small r and h are fixed. I told you given cone. Small r and h are fixed, but capital R and capital H are changing in such a way that what is going to be the curved surface area of a cylinder? What is the curved surface area of a cylinder? Is it not 2 pi r h? Correct? It is 2 pi r h. Now see, in this problem, what value are you supposed to maximize? The right circular cylinder has the greatest curved surface area, means the curved surface area has to be maximum, for which we are, since this chapter falls under the applications of derivatives, we need to take the help of derivatives to solve this problem. But we are clear with one fact: you can differentiate something only if the given function depends on one variable. Now I asked you a question. Capital R and capital H are two variables. So it is our responsibility to convert it into one variable. Now you will get another doubt. Sir, how do I know whether I need to choose capital R or capital H? Now read the question. They told radius of the right circular cylinder. So ensure that capital R is the problem and find capital H in terms of other parameters. How will you do that? Guys, am I clear with my logic till now?
Yes, sir.
Right? So if I take this as alpha, this also is going to be alpha logically, correct? So if I take them as alpha, this is capital R, then if I take tan alpha from the right angle triangle ABA, see there are two ways to solve again. You can either go with trigonometry or like the one which is given in your textbook where they use similarities of triangles. I'm more comfortable with trigonometry because it solves job easily. So tan alpha is equal to AB divided by B. Wait, again charge is over. You guys write no tan alpha is how much from both the right angle triangles. Okay. So how much is tan alpha?
AB by B, sir, and it's also
AB
equal to AC by DC.
So small h minus capital H divided by R. Similarly, tan alpha here is going to be small h divided by small r. So small h minus capital H divided by R is equal to small h by R. Okay. So what is capital H?
Capital R into H by R minus small h.
Correct, brother?
Yes, sir.
I don't think so. Small r h minus capital R into H. Correct? Is this right?
So now it's correct, sir.
Weird, I still feel something is missing because this is dimensionally wrong. Okay, let's solve it. So H, can you guys do it and tell me that RH minus small r capital H is equal to capital RH. So H will be equal to RH
RH minus RH by R, sir.
Sir, negative sign should come now, sir.
I took it, no? I took
Okay,
RH to the other side, this one to the other side. So curved surface area, if I call it as A, it will be 2 pi capital R into small RH minus capital RH divided by small r. Okay. Now dA divided by dr is equal to 0. So A I can write it as 2 pi small r into capital R into H minus 2 pi r square into H the whole divided by R. So if I differentiate it, what do I get? I'll get 2 pi r H minus 4 pi r small h by small r is equal to 0. If I do this, see, Mithun, observe, I'm cancelling 2 pi, 2 pi. I can take h also to the other side. In this case, why did I take h to the other side? Because I'm damn sure that h is not equal to 0.
Okay, sir.
Okay. So this will be 2 times the. So I'm getting small r is equal to 2 times capital R. So when small r is equal to 2 times capital R, take this and substitute it here, you will get the value of h. Sorry. Yeah, do that. Did you understand how to solve the problem?
Sir, but how can we cancel 2 pi RH? That is the 2 pi from RH and 4 pi from 4 pi capital RH, sir.
I put 2, no. Listen. You're saying 2 pi r small h minus 4 pi r small h is equal to 0. So 2 pi into h, I'm taking it outside. R minus 2r is equal to 0. 2 pi h can go to the other side because 2 pi is not 0. H is also not equal to 0. So small r will be equal to 2r. So take it and substitute it here. Capital H will be equal to 2RH minus RH
We'll
divided by
get H by 2, sir.
H by 2.
Be in terms of R, right, sir?
Okay. What is our job? We need to prove R is equal to 2H.
We can take that R equal to H's and put R by X equal to H and then find, sir.
Where R is equal to X.
In the first step, we took R equal to XH.
But we don't know what is the value of X. No? That is what we need to find. See, that is what we need to find. We almost solved
Yes,
the
sir. Sorry,
problem.
sir. I got confused.
Yeah. we need to prove that h by r is equal to 2. Then we'll get the answer. One minute, wait. First of all, I should have taken.
Sir, you differentiated dA by d capital R, no, sir? So then the denominator, there was small r.
Yes, sir. The
What happened to
denominator
that?
small r. We have to
Denominator-
differentiate small r
We
also.
didn't differentiate.
No
the
need, no
small r
need.
in the
No
denominator.
need. The smaller is constant, no?
We have to multiply it once, right, sir?
No need, no need. If you do that also, you'll get r is equal to 2r only. See, small r is equal to 2 times capital R.
Should be r square in the denominator, right, sir?
No need, no need. That's what I'm saying. You need not differentiate the small r because small r is not a variable. Small r is the radius of the cone. Small h is the height of the cone. They both are constants. No, that's what I meant by fixed dimensions. So you're doing dA by d capital R. No, that capital R is what is the variable.
Yes, sir, but constant is there's a denominator, no, sir. Then it will come 0, no, sir. 0 should come, right, sir?
Half into x square na will make this a 0. You'll make half into 2x na. So that 1 by r, I took it outside. That's it. No problem in differentiation. I think everything is right. Small r is equal to capital 2r. I'm just missing an expression to write it. That's it.
Can we try with Pythagoras theorem something, sir?
No, Pythagoras theorem, you need to know the hypotenuse. No, we don't know the relation between the slant heads. So small h minus capital H divided by r is equal to capital H divided by r. Okay. So this one you understood, no? So if I put small r is equal to 2r, what will I get? H minus capital H divided by r is equal to h divided by 2r. This and this will get cancelled, which implies capital H is equal to h divided by 2. What is the use of it? What mistake did I do? The process of explaining it, I missed something. No? That's the radius of the right circular cylinder of greater cell.
Sir, could you show questions for a minute, sir?
See, actually, what has happened is this height is also capital H only, and this radius is 2 times capital R.
Sir,
Tell me.
sir, we know the value of AC, right, sir, which is the height of the cone.
Okay.
And CD also, you know, no, sir, the radius of the cone is smaller, sir.
Mhm.
So then we can find the hypotenuse and calculate according to Pythagoras theorem, no, sir. We can find AD, sir. We can find AD as root of h square minus r
Okay,
square.
but you will find it. But what are you going to get out of it?
Sir, we can equate
Okay.
both of them. We can equate both the Pythagoras theorem from both the triangles, from triangle ABE and from triangle ACD, no, sir. Sir, and then we will have one constant and one variable, which we can equate and substitute in the tan alpha and find, no, sir.
No need. That's how complicated. See, first
Sir,
of all, see,
given that
this is capital H, this is capital H. This capital R, this is 2 times capital R. That is the meaning of statements that we have got.
sir, I have a doubt, sir. Here's given that curved surface area is the grade 2, so we should take maxima, right, sir? Here, we have to differentiate twice.
No, and you not differentiate it twice. I'm saying if you differentiate A with respect to R, then what are you getting? It gives a relation between small r and capital R. That is the radius of the cone and the diameter of the diameter of the cylinder. So capital R is equal to R divided by 2. They're asking us to relate the radius to something. I mean, missing something. I'm extremely sorry that you actually solved the problem. You know what I had been reading the question as is half of the height of the cone is what I was thinking. So they're saying prove that the radius of the right circular cylinder is half of the radius of the cone. So small r is equal to capital 2R means, I'm sorry, it was my mistake. So there is nothing to do with the heights. That is what I was thinking. So capital R is equal to R by 2. So radius of the cylinder is equal to half of the radius of the cone. Half of that of cone. I thought half of height of cone. Guys, are you able to understand?
Yes, sir.
Yeah. So that was a mistake. But did you understand how to solve? I want you guys to try one more problem. One problem you try. Let me see what are the mistake you guys are doing.
Sir, so we proved radius of the cone, radius of the cylinder is equal to half of the radius of the cone, right, sir?
Yes, half of that of cone. Now I read it as half of height of cone. Okay.
Sir, small r is the radius of the cone, right, sir?
Yeah, radius of the cone.
Sir, then we are proving it to the radius of cone, right? R by 2 only we are proving, no, sir. Then
I've proved it already. For capital R is radius of cylinder. Small r is radius of cone. So radius of the cylinder is equal to half of radius of the cone. Done.
yes, sir.
Small. That's it. So
Okay, sir.
now you guys try the 23rd problem. Try the diagram and then prove that the volume of the largest cone that can be inscribed in a sphere of radius capital R is 8 by 27 of the volume of the sphere. Done, guys? Right. So I'll draw the diagram. Please check this. So prove that the volume of the largest cone that can be inscribed in a sphere of radius capital R. So you have a sphere of radius capital R, and you need to inscribe a cone into it. Okay. This cone should have the largest volume. If that is the case, then we need to prove it is 8 by 27. So what are we supposed to prove? Volume of the cone is equal to 8 by 27 times the volume of the sphere. How to proceed? Wait, are you there?
Yes, sir.
How to do this problem? Just tell me, I'll create the equations. The remaining part you guys can solve it.
The volume of cone is equal to 8 by 27 volume of sphere. We can substitute the formula, simplify it.
So how do we solve? Volume of cone is equal to 4 by 3 pi r cube. Okay. So prove that the
That's
volume
for
of the
sphere, right, sir?
in a sphere of radius capital R. Okay. So if I take the radius of the cone to be R and the height to be H. So volume of cone is how much? 1 by 3 pi small r square into H. Now how many variables do you have?
3, sir.
So no, what are the 3 variables? There are only 2. Only cone is varying. The sphere is given, no.
Yes, sir.
So capital R is given. Okay, volume of cone is dependent on small r and H. Correct? So we need to make the volume of cone as a function of one variable. For that, what we do? We can make r is equal to root of r square minus h square. Take that and substitute it there, then you will get the answer. So volume of cone will be equal to 1 by 3 into pi into capital R square minus h square into h. So volume of cone is a function of height. Differentiate it, equate it to 0, you'll get the value of h. Once you get the value of h in terms of capital R, substitute the value of h here, you will get the value of small r in terms of capital R. Once you get both, take that and substitute it here, then you will get the answer.
Okay, sir. Understood.
Okay, try it out. So the question that we need to ask in every problem is, we need to ask how many variables are there. Okay, if you get the answer to that question, you will be able to solve any kind of a problem. This is the outline. Okay.
Sir, can I again say the last step, sir? What to do after finding the differentiated product?
Differentiated part, you will get h is equal to x times r. You will get small h in terms of capital R. Take that small h in terms of capital R, substitute it here. You will get small r in terms of capital R. Once you get these values, let's see, for example, this might be 2, this might be 3, something like that. Okay. Take these two values and substitute it the volume of cone. Then volume of cone will come in terms of capital R. then divide volume of cone and volume of sphere, you will get the answer as 8/27. Can you try
Okay,
that?
sir.
Okay, try that out. If you don't get it, let me know. But definitely try and let me know. Okay,
Yes, sir.
that's it, guys. That's it. Okay, so remaining part is left to you for you all to solve. So there are no more doubts. We can wind up. Okay, that's it. Right?
Thank you, sir.
Sir, this week test will you ask approximations, sir?
No.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Yeah.
sir. Thank you, sir.
Thank you, sir.